Hey, teacher.
What's that?
I'm gonna have to log on with somebody today. My laptop broke.
That's perfectly fine. Those things happen.
I can still do the homework in the library, obviously, but I just need to stand up. Might be until probably won't get it fixed till next week.
Yeah, so I just use like the university, things to do your assignment. You should be fine.
Okay, cool. I didn't know if you're doing like in-class assignments.
I'm gonna do some in-class problems, so you guys probably want to look off each other just to make sure,
Well, I mean, I didn't know if there's anything we had to submit in class.
No, you're all good.
I appreciate it.
Okay. All right, good afternoon. Let's get started. Okay, so a few announcements that you want to kind of keep up on here. So the exam 1 due date's already passed. The homework is going to open up today at 5, and I'm going to extend the due date a little bit. And the reason why is I'm going to change the schedule. So this is why I just posted the announcement on it. I'm going to push some of the material back to Tuesday, okay? So we have a little more time to do things carefully and make sure we understand things. There's also a survey quiz that I put online, and in regard to exam 1. So, I like a lot of different aspects of this online technology. When it came out 10 years ago, I was very much against it. I'm kind of old school in some ways, but I've really become convinced it's good. However, like any type of technology, you have to be careful how you use it, right? So when people just kind of throw technology at you and you don't think about how you use it, it usually doesn't turn out very well. So what I want to do in the survey is I kind of want to get your opinions. I want to find out, what you had difficulties with, what you liked, what you didn't like, what worked, what didn't work, okay? And if you have any other comments after the survey, feel free to go ahead and add those. Everyone that completes the survey, I'll give you 2 extra points on exam 1, okay? So hopefully that will help a little bit. So any questions about any of that? Everybody's good? Okay, so what I want to do today is I want to pick up where we left off last time. We were looking at these practice problems from Chapter 7, so if you want to go ahead and open your laptops up. If you don't have a laptop and you want to look off of someone else, that might be a really good idea. Feel free, right? The more the merrier. And I want to continue working these problems. And kind of what I'd like to do, today is I'd like to do these problems in the way that you're going to do the homework. In other words, when you're working on problems and you have a difficult time, use the hints, okay? But then if you don't get it, ask me. I want to kind of use this as like simulation. Yeah, no.
I have a question about the exam. Do I just come to you after class?
No, actually, why don't we wait till Thursday and kind of postpone those? Because Thursday on the schedule I showed, I'm going to go through the whole exam. And then after we go through the whole exam, if you have questions, feel free to ask me, okay? All right, good. So why don't we get started? So I think we left off last time. Was it problem 6? Let me see. Problem 5? Okay, thanks. And so I want to review a few things that are going to be important for us to know. So what we were doing last time was we were talking about the normal distribution. So we had this sort of notation, right? When we wanted to denote a normal distribution, we had this sort of notation where we had this n standing for a normal distribution, and this was the mean, and this was the standard deviation. And so, we talked about how to compute probabilities, right? So if we're not using the empirical law, And we're given a specific data value, and I want to know, say, the probability that the random variable is less than or equal to this specific value. We said that the way we're going to start thinking about this from now on is this is going to be the area under the curve to the left. So this is this probability, okay? And then we saw in Statcrunch how to do that. So how do we compute probabilities in Statcrunch? Well, we have to first of all go to Stat. So if I want to compute these probabilities in Statcrunch, we're going to go to Stat. And then we're going to go to Calculator Normal, right? So we said this is what we do. Calculators Normal. And this tells Statcrunch that I want to do a calculation with the normal distribution. Okay? And so when you click this open, we see this little window here pop up. And so the first thing you have to do, you have to tell Statcrunch which normal distribution do you want to do a calculation with. And what it's really asking for is it's asking us to specify the mean of the standard deviation. Okay. And so we talked last time about how to compute probabilities that way. Now, one thing we're going to start using more and more is we're going to start using the standard normal. And so how we got the standard normal distribution was we computed the z-score. And what we talked about last time was we said that if we start with a random variable that's a normal distribution, and we look at its z-scores, the z-scores actually come from a standard normal distribution. And so this looked like this. And this was a standard normal. And last time we worked with the standard normal, computing probabilities. And really, it's just the same as any other normal distribution, right? It just has a specific mean and a specific standard deviation, okay? So we're going to pick up from there last time. And let's see, so we're on problem 6, I guess. Okay, so it says here that we have a daily exchange rate for a 5-year period between two currencies, and that exchange rate is modeled by a normal distribution, and the mean is 1.847, and the standard deviation is 0.015. And so it's asking us to compute various probabilities using the empirical rule. So let's go ahead and write down what this distribution looks like. So this is the exchange rate. It comes from a normal distribution, and we're told that the mean is 1.847. And of course, in yours, it's going to be a little different, right? You can go ahead and write down whatever yours is, and the standard deviation is 0.015. And it's going to ask me to use the empirical rule. When I'm using the empirical rule, it's not quite the same as Statcrunch, okay? I'm going to get numbers that are a little different. I'm usually going to draw pictures. So it helps when we're using the empirical rule. It helps to draw pictures. I'm going to actually draw this distribution. In other words, what I'm going to do is I'm going to sketch this mean, and then I'm going to go 3 standard deviations on both sides of the mean. So let's go ahead and do that and see what we get. So my mean here is 1.847. And I'm going to go 3 standard deviations on both sides. And so all I'm going to do is just add 0.015, right? So I do that, and I'm going to get 1.862, 1.877, and 1.892. Okay. And then I'm just going to subtract 0.015, right? So it's going to be 1.832, 1.817, and 1.802. My distribution patterns like that. Do you have to draw pictures? Well, no. I mean, you don't have to do anything, right? You don't have to draw pictures. Just like I don't have to, have a map to drive to Columbus, Ohio, right? I could probably figure that out on my own. But chances are I'm going to make mistakes, okay? So pictures kind of keep you really grounded. They keep you from making those sorts of stupid mistakes that cost you points. Okay, so now we can start to answer some questions. So what's the probability that a randomly selected day during this period, a unit of currency B was worth more than 1.847? Okay, so if I'm going to translate that into math, what I want is the probability that the random variable is greater than 1.847. And what's that going to be? That's an easy one, right? What is that? What do you think? 50%, right? Because the mean is the median, right? So that's 50%. That's an easy one. So we have to enter it in percentages, so be careful. Okay. All right, good. So what's the probability that a randomly selected day during this period, the currency is worth less than 1.832? So I want the probability that a random value is less than 1.832. So here it's not a bad idea to start to draw some pictures, okay? So this is the area that I'm interested in. The probability that it's going to be less than 1.832 is the area in this tail. The question is, what is that area? What is that probability? You want to take a shot? Go ahead. So let's think for a second. This value, what's important about this value? How many standard deviations below the mean? It's 1. Okay, and what do we know about one standard deviation? Close. So let's just puzzle through it carefully. So what do we know about one standard deviation? There's what in here? 68%. Okay. So now let's kind of follow it through. There's how much in these two tails?
32%.
32% just subtracted from 100%, right? And then I'm going to divide by 2, right? So there should be 16% in this tail. Okay? So some of this is kind of just a review of what we did last time, right? All right, good. And finally, what is the probability that on a randomly selected day the currency was worth less than 1.802? Okay, so now we're way out here, right? So for the last part, I want the probability that I'm less than 1.802. And when I look at this, again, what's significant about this? Well, it's 3 standard deviations from the mean, right? And I know between 3 standard deviations, there's what, 99.7%? Okay. So there's 0.3% in both tails, and therefore there must be 0.15% in this tail. Okay? And you have to be careful. That's 0.15%, right? Okay? So the last question is asking us which is more unusual. Okay, so it's giving us 2 different values. So it's saying, first of all, what's more unusual? The probability that we get a value less than 1.808 or the probability that we get a value more than 1.881. So let's take a look at this for a second. So 1.808, where is that? That's here, right? And the other value is 1.881. That's way out here. So how do we compare those two values? We can't use the empirical rule, right? So how do we do that?
See which standard deviation is closest. So one's closest to the second standard deviation, one's closest to the negative third.
Okay, so if we think about standard deviations, right? This is 2 standard deviations below, and this is 3 standard deviations below. This is 2 standard deviations above, and 3 standard deviations above. That doesn't help me really, does it? So what am I looking for here? What am I trying to figure out? I'm looking at the z-score. That's how I compare these two, right? So notice that I can't get any help here because they're both basically between 2 to 3 standard deviations away. So I have to actually compute the z-score, right? So in this problem, you're going to have to actually compute the z-score. So the z-score for this one will be what? 1.808 minus 1.847 divided by our standard deviation of 0.015. Of course, in your problem, it'll be different, but you're going to use the same sort of logic, right? The z-score here will be whatever this value is minus whatever you have for the mean divided by whatever you have for the standard deviation. And if we go ahead and just compute that really quickly, use a calculator here. So we have what, 1.808. 1.847. And actually, you notice I don't even really need to divide by the standard deviation, okay? I mean, I will, but I actually don't have to. Just that number alone would tell me. But I'm going to go ahead and divide 0.015. So this z-score is minus 2.6. And if you do the other one, then you can make a determination. So 1.881. And I get 2.26. So this number is positive. It's larger. It must be the more unusual, right? Does that sound right? No. What's wrong with that argument?
It doesn't matter what the sign is. It just matters the distance from the mean.
Right. So what matters is actually the size of this number, right? Not the algebraic sign. So this is more standard deviations away. So this is going to be the more unlikely value, okay? So the larger the magnitude of the z-score is, the less likely it is. Okay? So any questions on that problem? These are what I kind of consider like basic calculations for us now, okay? Okay, so I'm going to let you guys puzzle through the next 3. 7 and 8 should be pretty easy. When you finish those, let me know and you can take a break, and then we'll work on 9 together. Okay. Excellent. Okay. So when you get both of those problems done, let me know, and you can go on break. And it isn't a bad idea. If you don't have a laptop, that's fine, but you can kind of look off of someone else and see how they're doing it so that you know how to do it on the homework.
You want to?
I was watching on video.
Song is your dance.
Okay, so this is our formula for z-score. We're going to actually come back to this, right? It's the beta value minus the mean divided by standard deviation.
You put a grade on, just go 1 minus. Hey, less on, oh, yeah. How do you do that?
So if you're on problem 8, you probably realized something, which is that that number they're giving you, you're going to have to write as a percentage in decimal form, right? Ladies. That's your first set of
I was assuming that it's a specific question on what pages of the chapter.
Can you read it?
It's the question starts with both. What age? I've never had the. I could just. Yeah, I mean, the rest are fine. It's fine. It's just one question. It's a slight job.
I think I'll read some.
Okay. Anytime to let's go. Thanks.
One step.
I'm sorry.
You know that
32, and then you divide that by 2 to get that half. Yeah, and then makes sense.
so he's asking for like 1.8. So there's 99.7%. So, and that's the last deviation. So you still have 30%. So 0.6. So like, since this is 99.7%, here, so 3, that's the equation. Both.
That's it. The money on the back. I don't know if it's saying that kind of good. They're like only the answer for the online.
Nine is really hard. So I'll just say one thing. 9 is kind of hard. So if you get stuck on 9, that's okay. We're gonna go through that. That's a kind of tricky. Good.
Yeah.
Yeah. What we started doing was put in the what's that called? And then we're trying to find what percentage by. Maybe I can chat.
If you want to do that, we can that.
Yeah, and so I could just like some general probability whatever numbers I have. Okay, so like these four will have the same as Because you know that all z-scores come from this distribution, all z-scores. And that's the
What you do, take, you find the exact action. So you find what's the value again? Greater than
thinking about it. How's it going down there? I'm sorry, I didn't have a chance to
I mean, sort of alright. I'm a little stuck on the second part of question 9, but like, I'm just waiting until we get to there.
Oh, I mean, so you got through 7 and 8?
Yeah.
Everything's good?
Yeah.
Excellent. Okay. And there's a lot.
I messed up this first one, so I'm going to do this somewhere. I figured out how to do So basically,
I said that unintended back to the last one. That happened multiple times though. Oh, you said it's people that have oh yeah, as soon as you graduate.
Oh, yeah, never mind. So you have to be careful.
Yeah, and then you have to like
Yeah, but almost all of them qualify. Yeah, but they offer. It's that grade.
no, that's not it.
It's that. No, they have. Yeah, the rating one. Yeah, but they don't. For nationals, they're voluntary. Oh, because you went to the military? Yeah, well, that's why they have national service and military service. If you're religiously qualified for it, you do national service. Want to do military service? Yeah, the national service is still have to do 3 years, like you still have to qualify. I was like, I've never been my entire Yeah, someone was, my friend walked in there and asked her, like, she said, you know, you have to wear certain type of clothing, so she has a woman in shorts. She doesn't fit at and they were right outside. Yeah, but you can't go into that section. Were they gonna maybe some more? How can you drive? I live right next to, like, once you walk through the gate, you just right in turn, like, right. Yo, what's up, Ellie?
That's what I just started.
Well, do you know what the church is?
Yeah, I just not gonna let you go.
In the old city, I also live there. I live right next to the hospital, like, building next to it.
It's just like.
Technically, a men's, where they go to study. Yes. It's technically a men's.
And that's why we have to use Statcrunch. If it was that easy, I could just use the empirical rule.
We all share that.
What if they call you?
Together.
The normal distribution, unfortunately,
This is why
It definitely depends on what field you're in. Yes. I mean, obviously you have
That's like let's go back to my knowledge from so long ago, but like it's like okay, so you've got like probability less than put that into some like negative value, like doesn't matter. So you've got like the standard deviation. But probably out like a number. Probability the thing is, like, you get the case, don't know probability percentage, we don't know what this bit is. But we did know a bit of it, it was like, it's basically this is how the thing goes, this is what the thing does. I don't know how you do it in Statcrunch, because I didn't let you do it.
Well, that's why she doesn't like very like that video that I watched about the one state and two state function. Like, first of all, that's not even like.
Yeah, I know, but that's literally nothing.
It's like on the table negotiation. So like. I think that's fine, I said something. Like one state, no, it's
Okay, so we'll take about 3 or 4 more minutes and finish up this exercise, and then we'll go on to problem 9.
So once we want it, you know, just have a negotiation.
We're going to get to that. Hold on.
Yeah.
We're gonna see if we do.
X minus
Yeah.
But what that means is that what was the question?
So we know the probability that's below this point is this, so we just don't know what it is.
But anyway, like I said,
Okay.
I think not
Say that. Five. I can put all the stuff in this back.
I don't know how to do the. Doing number 2. So just go to Statcrunch. Yes, stat. So calculators and then
And that's a piece of the puzzle. Okay, do you guys want to look at number 9 now? You ready? Okay. Number nine is a different sort of problem than what we've been doing. So let me kind of break this down, okay? So here's what's going on in 9. We're given a normal distribution. So for example, in my part A, it gives me the mean, it gives me a data value and tells me the percentage above that data value, and it asks for sigma. So here's my starting point, okay? So I know that X has a normal distribution, and I know that the mean is 21, but I don't know sigma, okay? Now, what I'm going to do in this, but I do know a data value, okay? I'm given the mean, I'm given a data value of 30, and I'm told that 30 is in the 80th percentile. And I'm told that there's 20% above 30, right? 20% of the population, so there's 80% below. So I know that 30 is the 80th percentile. I'm sorry, is the 80th percentile, that's right. Make sure. Yeah. Now, how am I going to get mu? So here's what I'm going to do. I'm going to use the z-score. So here's what I know about the z-score, right? And I know some of these values. I have a data value, 30. I have the mean, which is 21. And if I could just get the z-score for that data value, I could solve for sigma, right? So from the given information, what I know is that the z-score for 30 looks like this. And the question is, what is the z-score for 30? That's the main question. That's what I have to figure out. How do I get that? So here's a fact that we have to know. What we're going to do is we're going to use the fact that data values and their z-scores have the same percentile. So here's the trick. So if you think about any normal distribution, I don't really care about this particular normal distribution, but if you look at any normal distribution, okay, mu, and there's one standard deviation above, 2, 3, right? Looks like this. So this is the standard picture we've been drawing. One standard deviation below, 2, 3. And now I draw the z-scores for this, right? So if I look at the z-scores, this has a z-score of 0, right? This points 0 standard deviations from the mean. This has a z-score of 1, right? A z-score of 2, and a z-score of 3. Notice this comes from a standard normal distribution, okay? That's important. This distribution looks like this. So here's what we want to take away from this. Notice that this is a data value, right? One standard deviation above. This is its z-score. These two values are in the same percentile, aren't they? For example, we know that this is in the 16th percentile. We just figured that out, right? This is also in the 16th percentile because in this, for the z-scores, they come from a standard normal, where the standard deviation is 1. So it's 1 standard deviation above the mean here, okay? So this also is the 16th percentile, okay? So here's the thing. If you tell me the percentile for the data value, I can find that z-score. If you told me, for example, I'm thinking of a data value that has 16% in its upper tail, I could then use that and I could find that z-score, right? I would go into Statcrunch and I would say, okay, if I have a normal distribution that has a mean of 0 and a standard deviation of 1, and I put in the percentage here, 0.16, it would give me the z-score. Then once I have that z-score, I can solve for sigma. Yes, no? What do you think? Okay, so here's what I'm doing. I'm taking the given information, I'm taking the mean, I'm taking the data value, I'm taking the percentile for the data value, and I'm finding its z-score. Okay? And the way I can do that is because the z-score is special. I know the distribution that the z-score comes from. And this is a really key fact. So I know that the z-score comes from a standard normal. So you tell me the percentile, I can find that z-score because I know that the mean is always 0 and the standard deviation is always 1 for the z-score. Let's go ahead and try it out of this problem, and you can kind of mimic this, okay? So first of all, there's 20% above, 20% above the mean. So obviously it can only be A or C, right? And it has to be AY because the probability is above, right? So I'm looking at that shaded part of the curve above. So that should be that. Okay. So now I'm going to use this information. So here's what I'm going to do. I'm going to start off with the z-score. I'm going to substitute the given information. So I'm given a data value of 30. And I'm given a mean here of, what do we say, 21. So from there, I'm going to get 30 minus 21 over sigma, or 9 over sigma. Now I'm going to find the z-score, okay? So I'm going to use the fact that this is in the 80th percentile. Which means so is its z-score. Okay. Which means that if I draw this picture now, right, I'm going to draw a picture of what's going on with the z-score. I know that the z-score comes from this normal distribution, okay? And there should be 20% in the upper tail. I can find that z-score, right? Using Statcrunch. I tell Statcrunch, okay, I want to work with a normal distribution that has a mean of 0, a standard deviation of 1, and has 20% in its upper tail. Can't we do that? That's a straightforward calculation, right? And that's how we're going to get the z-score. So let's go ahead. I'm going to do it in mine. Go ahead and do it in yours, whatever your data value is. I'll do it in mine. And we'll see what we come up with. Notice something interesting. When you go to Statcrunch and you want to calculate something with a normal distribution, it naturally goes to the standard normal, okay? Because that's the one that we're usually working with. So I want the probability less to be 0.8. And I end up getting a z-score here from Statcrunch of 8416. Okay. Now I have my z-score. And I can solve for sigma, right? Okay, and that's how we get sigma. Be careful when you get the z-score, don't round it off, okay? Rounding off can cause error. So try to use at least 4 decimal places for that z-score. And so let's make sure this isn't a figment of my crazed imagination. 6. And I get 10.69, and they want you to round it to 1 decimal place, so it should be 10.7. Okay. So I'm going to let you go ahead and try it on yours. Are there any questions about this? So notice that there's 2 keys in this problem. The first is that you have to know the formula, or at least know how to find the formula for the z-score. And the real trick is realizing that if you're given the percentile for the data value, that's also the percentile for that z-score. And because you know the distribution that the z-score comes from, it always comes from this distribution, you can figure out the value that corresponds to that percentile. Okay? That's where we're going with that. So why don't I let you go ahead and play with that for a little bit. Try the second problem. Notice that part of it is really easy. Notice I didn't do any work at all. This part's really easy, right? It's just really getting the z-score. That's the whole problem in essence, right? So go ahead and work on that. See what you come up with.
Not really facing, but just stuff like that. Normally you're
It just means you have a really long one.
Like my three shifts are the only way to do it.
Okay, so now we're to the fun part. I want to do the last problem for today, which is finding the mean. But notice it's kind of a variation of this sort of problem that we're doing, okay? Okay, so I'm just going to click whatever and just get through this. Okay, so the last problem's asking us about the mean. And who wants to, well, I'll tell you what, I'll use my problem. I'm just going to, whatever. Okay. Okay, so this problem's now saying that you have a standard deviation. If you have a normal distribution, the standard deviation is 4.6. We have a data value of 80. There's 85% below it, and I want to know what mu is, okay? So notice it's the same sort of problem, really. Here's what we're doing. So what we're told is we're told that x is a normal distribution. Here's what we're given. We don't know the mean, but we know the standard deviation, and you can write down whatever yours is. Mine's 4.6, okay? So I'm given the value of sigma, which is 4.6. In my problem, I'm giving a data value, and that data value is 80. And what I know is that 80 is in the 85th percentile, because the probability that I'm going to get a value less than 80 is 85%. So I know that this is the 85th percentile. Okay? And I want to know what is mu. So the same sort of approach. I'm going to start with my formula here. I know that my data value is 80. Okay? I know my standard deviation is 4.6. So I'm going to say 80 minus mu over 4.6. Now, sometimes people use a certain notation that's very useful if you understand it. This 80 is the 85th percentile. I don't know what the z-score for 80 is, but I know it's in the 85th percentile, right? So what I'm going to do is I'm going to find the z-score that's in the 85th percentile. And sometimes people use this notation, and we may use it now and then. They do a z and they put this on the bottom. And this tells me what percentile z is, okay? So that's what I want. Because this is the 85th percentile, so the z-score has to be the 85th percentile, okay? So let's just draw a picture really quick. This is what we want to do. This is the standard normal. I want to find the z-score that has 85% in the lower tail, right? And I can do that on Statcrunch. So that's what you want to do, okay? Use the percentile for the data value you're using and get its z-score. So I'm going to go into Statcrunch. And I'm going to say, okay, I want a data value. And one thing you have to be careful of is be careful where you're putting what, okay? Remember, this is always a data value. X is a data value, right? I don't know what this is. This is the percentile, or the probability, right? So I want that. I'm going to put that in there. And I click on compute, and it gives me the z-score. So it tells me this z-score is 1.0364. So now I'm done. 1.0364 is equal to 80 minus mu over 4.6. And now I can solve for the mean, right? I multiply both sides by 4.6 and get 80 minus mu, and then subtract 80, right? and that's going to be minus mu. I'm going to work this value out and then just change the sign to get mu. So if I do that, get 1 point and it's 4.6 minus 80. And my answer should be 75.23. That should be my final answer. Okay. So this should be my mean. Okay. So notice we're always going back to this percentile. The percentile for the data value is the same as the percentile for the z-score. And since I know the distribution for the z-score, this is probably the most important thing to remember today, is that the z-score always has this distribution. So you tell me the area in the tail, you tell me it's a z-score, I can use that in Statcrunch to get the mean. Okay? Okay, I'm gonna let you guys finish that up. If you have any questions, go ahead and ask. So 2 main points: formula for the z-score and the fact that the percentile for the data value is the same as its z-score. And this notation you may find helpful. Okay, this notation where I put the percentile of the z-score. Notice this is z.085. This is the z-score that has 85% in its left-hand tail. That's a notation that you might find useful. Okay. All right. And when you're done, you're free to go. All right. You need a high grade. Really? What high grade? That's 16 high grade.